For factoring in cases where a, the first value, the leading coefficient, is greater than 1, I like to use the diamond method. Sometimes you'll hear it referred to as the Xbox method because we can just draw an X, and then we use the logic that you used yesterday. I'm hoping that a lot of you like that kind of quick thinking, almost like a logic puzzle. For this value up top, it's always going to be the product, the multiplication of A and C. And down here, we need things to add up to sum to B. So if I look at this trinomial, 3p squared minus 2p minus 5, it's clearly not a special case. I don't see a GCF. So I'm going to write up top the product of A and C. 3 times negative 5 will get negative 15. Down here, I know I want things to add up to B, so I need values that add up to negative 2. Some people are really quick with this. If you want to make a table and think of all the factors of 15, think about how the positive and negatives could play around with each other. But I would really look at this as the values are probably about 2 apart. I know at least one of them is going to be negative, is at least my first thought. And from there, hopefully we can figure out that it should be negative 5 and positive 3. We're going to use that information to split our middle term. So I'm going to rewrite that trinomial as 3p squared. And then since negative 2p could be rewritten as negative 5p plus 3p minus 5, we're going to break that middle term apart. From there, I'm treating this almost like 2 separate problems. I have the first half and the second half. If I ignore the second half for a second, I'm just going to look for a GCF of the first piece. In 3p squared minus 5p, I could factor out p. And I'm left with 3p minus 5. In the second half, I don't have a common factor. So I'm going to factor out a 1. And from there, I'll have 3p minus 5. The big thing to notice is that in each of these binomials, or that we have the same binomial here. If we want to take it a step further and almost undistribute, we could say that p plus 1 was distributed to 3p minus 5. So recognizing these GCFs as something that can pull back together as a binomial. And this is hopefully our final answer. The last thing I'm going to do is FOIL it out, hopefully a quick mental check at this point to see if it works. 3p squared minus 5p plus 3p minus 5, that'll work for me.